Hi friends, welcome to Sada Learning Hub. You are with me, Sadashiro. Today's session we are going to learn about list interface in the collection framework. List interface. See this picture. List interface is an list is implementing from the collection interface. Collection is an implementation interface of list interface. Now list interface, it is the child interface of collection. If you see this one picture, it is the child interface of the collection. This is the parent and this is the child. If we want to represent a group of individual objects where duplicates are allowed and insertion order is preserved, then we should go for the list. We can different duplicate objects and we can maintain the insertion order by means of index. Hence index plays very important role in list. We can differentiate duplicate objects. For example, if you are inserting into the if you are adding the elements into the list with the duplicate elements, the in duplicate objects, we can maintain the insertion order by means of index. Hence index plays very important role in the list. List interface defines the following specified methods. These are the some of the methods available in the list interface. Now I can show the documentation directly. It is very good for you. See here, list interface. If you come into the list, if you come to the list, these are all the methods available in the list. These are all the methods available in the list. If you see this one, list is an interface. See all the no implemented classes. See the super interfaces. List is the interface. What is the super interfaces of list? There is a collection. This is the super interface of the list. Next, these are the methods available in the list. If you see this, these are all the methods available in the list. Here, if you see here, these are the description of the method. All the methods below, some description also available. If you, for example, I can tell the one example here. Add method. Add method means appends the specified elements to the end of the list. It's a adding the elements to the end of the list. If you see this one, I can show one more example. Size means it retains the number of elements in the list. These are all the methods available in the list. List is an interface. Next, I'm going to discuss about array list. Here, array list. Array list is a class. If you see here, array list is the class. Array list is implemented from the list interface. List is implemented from the collection interface. This is the hierarchy. If you're coming to the array list, the underlying data structure is resizable array or growable array. Duplicates objects are allowed. Insertion order is preserved. Heterogeneous objects are allowed. Null insertion is not possible. If you are going to the array list, there is no chance to insert the null values. Now there is some constructors are available in the array list. I can show the constructors. See here, array list A is equal to new array list. It creates an empty array list object with the default initial capacity 10. If the array list reaches its max capacity, then a new array list objects will be created with the new capacity by using this formula. Current capacity into 3 by 2 plus 1. Next, one more constructor. It is a parameterized constructor. It takes the size of an array. It creates an empty array list object with the specified initial capacity. Whenever we are creating an array list with the initial capacity value, it automatically creates that particular size. Next, one more constructor is available in the array list. This takes the collection C. Means it's a parameterized constructor. It takes then a collection object, creates an equivalent array list object for a given collections. That is it, this constructor meant for inter conversion between a collection objects, that it is to dance between a collections objects. Now I can show example here. See, I'm creating a one class that is called ArrayList demo. In the ArrayList demo, this is the main method. In this main method, I am creating an object of ArrayList. Now, I'm adding the elements into the ArrayList by using the add method. See here, a dot add. I'm adding the a value. A dot add of 10. A dot add of a. Like what, I'm adding the elements into the array. After that, I am printing that system.out.println. It prints like this. It prints like this. After that, I am removing the elements from the array by using. I am removing the elements from the array list by using the remove method. After that, I am printing. It prints only three values. After that, I am adding the element into the array list with a particular location. Second location, I am inserting the m value. After that, I am adding the element into the array list, that is the n value. Whenever we are adding the with the single argument, automatically it adds the end of the array. Whenever we are saying the particular position, it adds in a particular position of an array list. When after that we are printing the array, it shows like this: a 10 m null n. Next, unusually, we can use a collections to hold and transfer objects to provide a support for this requirement. Every collections class implements serializable and clonable interface. ArrayList and vector classes implements random access interface so that any random elements we can access with the same speed. Random access interface present in the util package and doesn't contain any methods. It is a marker interface. Random access method. Random access method means we can access the elements randomly. Randomly means whatever we want. That is a random access. Random access interface present in the java.util package. It is an marker interface. Next, I'm going to discuss about what are the differences between array list and vector. Array list, no methods is synchronized. If you are going to the array list, there is no methods synchronized. And if you are going to the vector, every method is synchronized. At the time of multiple threads are allowed to operate an array list object, and hence array list object is not thread safe. If you are accessing the multiple threads at a time in the array list, there is a getting the exception, concurrent mapping, concurrent access exception. Whenever we are going to the vector, at the time of only one thread is allowed to operate on vector objects, and hence vector object is a thread safe. In array list is relatively performance high because threads are not required to wait. If you're coming to the vector, relatively performance is low because threads are required to wait. ArrayList is not a legacy. It is introduced in Java 1.2 version onwards. If you going coming to the vector, it is a legacy collection framework. It is introduced in 1.0 version onwards. Next, I'm going to discuss about how to do ArrayList with synchronized. Collection classes defines the following method to return the synchronized version of a list. If you are using the synchronized list, it takes an argument list interface. Automatically, it takes the synchronized version of array list. Similarly, we can get the synchronized version of set and map objects by using the following methods: by using synchronized set and synchronized map. Array list is the best choice if our frequent operations is retrieval. Array list is a worst choice if our frequent operation is insertion or deletion in the middle because it requires the several internal shift operations. Next, I am going to discuss about linked list class. It's a linked list. Linked list is a class. It is implemented from the list interface. List is the implemented from the collection interface. The underlying data structures is a double linked list. If our frequent operation is insertion or deletion in the middle, then linked list is a best choice. If our frequent operations is retrieval operations, then linked list is a worst choice. Duplicate objects are allowed. Insertion order is preserved. Heterogeneous objects are allowed. Null insertion is possible. Implements the serializable and clonable interfaces but not random access, not a random access. Usually, we can use the linked list to implement the stacks and queues to provide the support for these requirements. Linked list class defines the following 6 specific methods. Those are those are the add first, add last, and get last, and remove first and remove last. We can apply these methods only in the linked list objects. These are the some constructors are available in the linked list. I can show what are the methods available and what are the constructors are available in the linked list. See here, linked list is the class. If you coming here, linked list the class. Now these are the methods available in the linked list. See, these are the constructors. It is a default constructor and it is a parameterized constructors, and their descriptions are available below the constructor, and these are the methods available in the linked list. These are all the methods available in the linked list. I can show one example on the linked list. If you come here, see, I'm creating a one example for the linked list. This is the linked list demo. In this main method, I'm creating a one object for the linked list. This is the linked list object. I'm adding the values. Dot add method is used to add the values into the linked list. After that, I'm printing the linked list. After that, I'm setting the particular position of that value. I'm setting the 0th position with the software. Next, after that, I'm setting the one more time with the 0th position with Venki. After that, I'm removing the last element into the linked list. I'm adding the first element to the linked list. After that, I am printing the all the elements in the linked list. Next, I'm going to discuss about vector class. If you see here, vector, the underlying data structure is resizable array or growable array. See this, vector is the class which is implemented from the list interface. List is implemented from the collection interface. Collection is the child class of list. List is the child class of vector. The underlying data structure is resizable array or a growable array. Duplicate objects are allowed. Insertion order is preserved. Heterogeneous objects are allowed. Null insertion is possible. Implements serializable, clonable, and random access interface. Every method present in the vector is synchronized, and hence vector is the thread safe. These are all the methods available in the vector. There are the methods available in the vector to add the objects into the vector by using the add method. These are the add method is a overloaded method. We can remove the elements into the vector by using these all methods. These are also overloaded method. We can get the element from the vector by using the these methods, and these are the other methods which is available in the vector class is a size and capacity. Size means it prints the size. Capacity means what are the total capacity of that vector. And enumeration means we can iterate the vector class elements. Next, these are the constructors available in the vector class. Default, first one is the default class, and second one is the parameterized constructor. It is the overloaded constructor. First constructor, it takes the initial capacity, and second constructor, it takes the initial capacity and incremental capacity. After third, fourth constructor is a parameterized constructor. It takes a collection interface. Now I can show an example on the vector class. If you see here, I'm creating a one class, that is a vector class. I'm creating a main. Now I'm creating an object of vector class. Now I'm printing the size of the vector. See, v dot capacity, it prints the 10. Now I'm iterating. Through iterating, I'm adding the elements. uh, Here I'm adding the elements I value. I means 1 to 10 values. I'm iterating in the iteration itself. I'm adding the values. After that, I'm printing the capacity of the vector. It shows the 10. Now after that, I'm adding the elements to the vector object by using the add element method. This is the a I'm adding to the vector. After that, printing the capacity of the vector. It prints 20. Next, I'm printing the values. All the values which is contained in the vector. Next, I'm going to discuss about stack. Stack is the class which is available from the 1.0 version onwards in the collection framework in Java. Is the stack. It is a child class of vector. Whenever last in first out order requires, then we should go for the stack. Stack is the last in first out. Whenever we are inserting the first element, it is come out to the last in first out. Whenever we are inserting the last, that is come out to first. So that's some of the methods available in the stack. These are the method push. We can insert the element into the stack. Pop means we can remove the elements into the stack. Peek means it returns the top of the stack without removal. And empty means it checks the stack is any elements available or not. Search means it search the elements into the stack. Now I can show an example on the stack. If you come this example, this is the stack demo. In this stack demo, I'm creating an object of stack. I'm pushing the elements. Push means nothing but insert, nothing but add the element into the stack by using the push method. After that, I'm printing the stack. Next, I am popping the elements from the stack. Pop means removing the elements from the stack. After that, I am printing the value. After that, I am printing the s dot peek means without removal, it takes the get the elements from the stack. Now, I am searching the element from the stack by using the search method. I am checking the empty method. Okay, these are the classes available in the list interface. These are all the array list and linked list and vector and this tag. These are the implementation classes of list interface. List is an implementations of collection interface. See, this is the hierarchy of list and list implemented classes.
Thank you so much watching this video. Hope this lesson helpful to you. Keep watching our lessons. Keep writing to us. Do not forget subscribe our channel Learning Hub because we have many sessions that would help you to develop our skills, and I will be back soon. Till then, you take care. Bye bye.